we start our work. Good morning, everybody, wherever you are, because why not? Why not a good morning? Especially when I finally woke up in the morning. It is 9:30 a.m. Finally, I made myself wake up at 8. Like, I put the alarm on 8:30 and I woke up at 8:15. So, yeah, I am faster than time, motherfuckers. So, now that we wake up early, well, okay, it came with a lot of sacrifices, by the way. I didn't go to gym last night. I wanted to go. It's 2 days in a row that I didn't go to the gym. Which is not happy, but when you want to wake up early, I had no other choice. I was out until 10. Yesterday I didn't have lunch until 8 p.m. So when I got home, it was like 10:30, and I could go to gym for 30 minutes, but I said no, let's make sure that we sleep at 12. Even then, because I was so hungry, I ended up eating for half an hour and I went to bed at like 1. So anyways, I have like 30 minutes, 1 hour sleep deficiency last night, and also 2-3 hours from the nights from Monday night. Yes, from Monday night. So a bit of a sleep deficiency. Hopefully tonight I can go to bed at 12, wake up at 8 tomorrow, and everything will be fine. What else? Yeah, let's start the work, then we will finish the work early, and then we go to the gym, we can go out, we can get everything done on time. I don't want to wake up at 11 anymore. Sometimes you have to, but like, let's not that be the regular situation or whatever. Yeah, it should not be the norm. It should be like one night or something. So let's wake up early and finish the work earlier. Alright. Four, three. Where are we, guys? I don't remember. I do remember. As we talked about, every time when you start your work, there is this 5 minute that you say, oh well, what happened yesterday? What happened yesterday? And you can find it out in 5 minutes. So not a big deal. You don't have to finish your work every day because there is always a tomorrow, always a tomorrow, always a tomorrow, do. And if there is no tomorrow, who cares if you finish your work or no. Okay, I'm here. Okay. We were talking about the uniqueness of the solution. I don't like both. Okay, both ways they suggested. I don't like them. One was comparing this intersection of asymptotes with the line sounds ugly. This one, the tangent line here also looks ugly to me. So Do you want to try the tangent line? Even though if it looks ugly, we at least can say something. I'm going to, just to make sure it looks ugly. So this one looked ugly. The intersection of the, even though from the curves it sounds true, but come on guys, it was so. Alright. So what we want to say is that we want to keep our shoulders straight. This motherfucking work is very difficult. You're always like this. That's why I put the, what is this? Stand or whatever, holder, so that I keep looking up. And you want to have another keyword that you do. Still, there are times that you want to write this stuff down. Actually, I used to lie down. I may do it now, who knows. If we are going to have a lot of writing and computations, I will go that mode. So, okay, tangent line for this curve. Eta of the oh, I'm not seeing anything, by the way. Canceling out, out, and minus. So this motherfucker should be equal to the slope of the line, which is 2 r plus 1/2 over sigma zeta I squared. Already shows 2r plus 1 over 2. Alright. But this is not true. Okay. I can only say one thing. It looks far uglier. So well, there is still a bit of a chance that still a bit of a chance that we don't need to compute sigma. We just want to compute the y at that point and say the y at this point is the bigger than the y on the line, right? So, but even then, this is power 3 and the solution for the slopes is power 3 and y is power 2. Anyways, I will give it 5 more minutes. That's it. Now y is alright, this is ugly. Yeah, it's, as I said, it is to the power of 2/3 and far uglier than the first equation. The first equation was just a polynomial that looked ugly. This one, this one is a mess. Let's look at the inequality. Let's look at this polynomial again. Maybe we can say why it is positive. R is between -1/2 and, well, when R is positive, it is positive, right? Yes. When R is negative, this is positive, this is negative, this is negative, this is positive, this is positive. I don't want to say. Okay, these are bullshit. One other thing comes to my mind is looking at Thibaut had a lemma about, okay, it's here, this kind of equations. Is our situation like this? Yes, it is like this. So he says, following parameterized equation of the unknown. We have a linear term and an inverse squared term, right? Yes. Assume that A is good and D is positive and increasing for some interval. Alright. For each lambda, define x tilde of lambda c lambda over b lambda. Okay, maybe that helps. And assume that x tilde, well, we have to check if it is. Assume that x tilde is decreasing over I while b is increasing. Then for each lambda in I has a unique solution, x lambda in the interval. For each lambda, which is very good, we can say. For each lambda in I, x lambda is greater than x tilde, the function is decreasing. Also, let's look at the solution. which is not very long. Maybe we can find a way in between without using, without converting our equation to the lemma he has here. F lambda of x. What is our lambda here, by the way? Our lambda is n. R. It is R, yes. The first property is obvious after observing that for each lambda in I, the function f lambda of x, lambda appearing on the left hand side of 39. Where is 39? What is this? Okay. 38 it means. Because 39 is after. This is my section. In his section, 39 is nowhere. Is it this? Okay, it is 39, but come on, 39 is this one. 38, I guess. Okay. Oh, b lambda should be greater than 0. Positive. Okay. Is it for our case? Is it positive and increasing in R? Our case, it is like this. This is our B probably. Well, it's not difficult to say if it is increasing or not, whatever it is. All right. Yeah, it is positive. And okay, we don't know if it is increasing or decreasing. So our situation is that we are on the left hand side of the one assembler. Where is that here? X tilde of lambda. C lambda over B lambda. It is actually, okay, C lambda over B lambda. What is C lambda over B lambda? It is where our line meets the asymptote, right? So here our C lambda over B lambda is when this term is 0 and when the line cuts the asymptote, which can be, where is this one? Which is this one? It looks like the origin, but it is not. Ooh. Zoom. It's like this point. So he's saying this is x lambda. Well, here is on the right hand side. Here is also on the right hand side of the asymptote. Good to know. Differentiating the previous equation. This part is probably the part because it is disgusting. We want to make our equation in the form of Thibaut's lemma, not using the proof. Alright. So let's use Thibaut's theorem, lemma. Also, when you look at Thibaut's lemma, it looks very clean, right? Because these big formulas and ratios are there just distraction. So I want to have an equation in the form of x minus 1 squared a over x b lambda x minus c lambda a over r. Again, back straight to mu theta I plus s mu omega. This is good, and I'm feeling good, and I'm feeling good. All right. Now this fucking ratio. Well, our case. So we don't have x minus 1. So well, we can. Yeah, we can. All right. Bing, 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 bing. Our x will be uh, do, 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 2 n minus 1 r minus 1 sigma ai theta I over 2 n minus 1 rt sigma theta I squared. That's it. So then we have t mu theta I plus mu omega squared over 2 t sigma theta I squared over 2 n minus 1 rt sigma theta I squared yep. I am getting distracted. I don't want to get distracted. Alright, 1 over x minus 1 squared plus t over 2 is equal to 2 r plus 1 half. Okay, this part I can copy and paste. This, and instead of sigma ai theta I should write x 2 n minus 1 rt sigma theta I squared over 2 n minus 1 r minus 1 x. Now let's do some cleaning, or just let me keep this here and we will copy and paste the whole thing. Paste. So now we have, alright, that's it. We have t sigma squared cleaned on both sides. What else do we have? Oh, okay, I don't even have that because we have a t over 2, which is disgusting. Alright, so our A is quite big thing. Our A, where is A? Here. A, okay. Okay, the way I can do this is minus theta 1 minus t over 2 and this is minus over 2 have to go. Okay, I have 1 t sigma theta I squared here that I can get rid of. Now we should check if the situation holds. A greater than 0. Is our A greater than 0? Well, t is positive. Let's assume t is positive. Yep. B is positive and increasing for some interval I. Where is B? Okay. Now B is ugly. B is... Okay, B also can get cleaned up. It's not a lot though. I see. What is B? B is 4 n minus 1 RT, right? 4 n minus 1 RT R plus 1 half minus n minus 3 R over 1 half minus n minus 2 R 2 n minus 1 R minus 1. Well, is this R? Is B increasing in R? Oh, is B positive? B is positive if R is positive. If R is negative, it's not positive. B is negative. R positive. Okay, so we cannot use this because, well, we already, even from those previous two, from the ugly polynomial, we knew when R is positive it holds. I have to go to restroom. That's it. detoxified and refreshed. I'm back. But I want to say this motherfucking. Okay, next video I will put this challenge on myself. I cannot use F word. That's it. Enough. I think I am saying it too much. Too many times. This equation we cannot use. We cannot use it. Because R is negative, right? R is negative. T is positive. I let T be positive. But what if R negative? Alright. One thing I have to check is for positive. R can be positive or negative. R plus 1 positive. That is positive. 1 minus half. 1 minus half. 1 half minus n minus 3 r. This is also positive. 1 half minus n minus 2 r positive. And the last one is 2n minus 1 r times r minus 1. This motherfucker. Fuck! Okay. This dear term is minus 1 is well, r is less than 1 over 2n minus 1. So this is negative. So this is negative. So when r is negative, actually it is good. So maybe it works. R positive be negative. But when r is negative, B is positive, which is good. So we will keep doing that. That's good. For R positive, our other methods, right? Give me that. R positive. Yes. When R is positive, we already know from the polynomial. So when R is negative, we are going to use this one. Great, guys. Good job. I don't know if we got lucky or no. Maybe if you write these equations in other forms, we have a simpler form. But for now, we are lucky. I don't know. We are always lucky. We are blessed with having my phone, my charger cube, my tablet, keyboard. They're in 2 books to put my holder on, which are pretty thick, and we don't read them. Thanks a lot. Control Shift A and goodbye.